Before writing a single line of Python code for security automation, you need a properly configured work environment. This chapter covers the essential steps: installing Python, choosing and setting up a code editor, creating isolated project environments, and verifying that everything works correctly. Each of these steps directly impacts your productivity and the reliability of the scripts you will write throughout this course. Why Python for security automation? Python has become the standard language in cybersecurity for several reasons. It is readable, quick to write, and benefits from an enormous ecosystem of ready-to-use libraries. Tools like Nmap, Metasploit, and Wireshark all offer Python interfaces or can be controlled from Python scripts. Security professionals use Python to automate repetitive tasks such as scanning ports, parsing logs, sending crafted HTTP requests, or building proof-of-concept exploits. Learning Python is therefore not optional in a DevSecOps context, it is a core competency. Understanding Python versions. Python exists in two major lineages, Python 2 and Python 3. Python 2 reached its official end of life on January 1, 2020, meaning it no longer receives security patches or bug fixes. You must always work with Python 3. At the time of writing, Python 3.11 and Python 3.12 are the stable recommended versions. When you install Python, always download the latest stable Python 3 release from the official website at python.org. Avoid Python 2 entirely, even if some older tutorials still reference it. A common confusion for beginners is the difference between the commands Python and Python 3 in a terminal. On many Linux and Mac OS systems, typing Python may still invoke Python 2 if it is installed, while Python 3 explicitly calls Python 3. On Windows, after a fresh Python 3 installation, Python usually refers to Python 3. Always confirm your version by running the command Python 3 version or Python version, and verify that the output shows a version number beginning with 3. Installing Python on Windows. Go to python.org, navigate to the Download section, and download the latest Python 3 installer for Windows. Run the installer. On the very first screen, you will see a checkbox at the bottom that says Add Python to Path. You must check this box before clicking Install Now. If you skip this step, your system will not recognize the Python command in the terminal, and you will have to fix the system environment variables manually. After installation, open the command prompt or PowerShell and type Python version. The terminal should display something like Python 3.12.3. Also verify that pip, the Python package installer, is available by typing pip version. You should see a version number along with the Python version it is associated with. Installing Python on Linux, Ubuntu or Debian. Most Linux distributions come with Python 3 pre-installed. To check, open a terminal and type Python 3 version. If Python 3 is not installed, run sudo apt update and sudo apt install Python 3. To also install pip on Linux, run sudo apt install Python 3 pip. This gives you access to thousands of third-party libraries that you will use throughout the course. Installing Python on macOS. On macOS, Python 3 is not always pre-installed or may be an outdated version. The recommended approach is to use the official installer from python.org, just like on Windows. Alternatively, experienced users may use the Homebrew package manager by running brew install Python 3. After installation, verify with Python 3 version and pip 3 version. Choosing and installing a code editor. A code editor is the tool where you will write, read, and debug your Python code. While you could technically use Notepad, a dedicated editor provides syntax highlighting, auto-completion, error detection, and many features that save significant time. For this course, the strongly recommended editor is Visual Studio Code, also known simply as Versus Code. It is free, open source, available on Windows, Linux, and Mac OS, and it is very widely used in both the development and security communities. Download Visual Studio Code from code.visualstudio.com. Install it following the standard procedure for your operating system. Once installed, open Versus Code, then open the Extensions panel on the left sidebar. It looks like 4 squares. Search for Python and install the extension published by Microsoft. This extension adds Python-specific features such as code completion, linting, automatic detection of code errors, debugging support, and the ability to run scripts directly inside the editor. Alternatively, some professionals prefer PyCharm, an editor specifically designed for Python and published by JetBrains. PyCharm Community Edition is free and offers powerful features. However, for beginners and for security scripting purposes, Versus Code is lighter, more flexible, and sufficient. Creating and using virtual environments. One of the most important concepts when working with Python professionally is the virtual environment. A virtual environment is an isolated Python installation that exists only within a specific project folder. It has its own set of installed libraries, completely separate from the global Python installation and from other projects. Why does this matter in security automation? Imagine you have two projects. One requires version 1.26 of the request library, and another requires version 2.0 of the same library. If you install both globally, they will conflict. Virtual environments solve this problem entirely. To create a virtual environment, navigate to your project folder in the terminal and run python 3m venv. This creates a folder called venv inside your project directory. To activate the virtual environment on Linux or Mac OS, run source venv/bin/activate. On Windows, run ven \scripts\activate. Once activated, your terminal prompt will change to show the name of the environment, for example venv. Any library you install with pip while the environment is active will be installed only inside that environment. To deactivate the virtual environment and return to the global Python context, simply type deactivate. For example, if you are building a port scanning script that uses the Scapy library, you would create a virtual environment for that project, activate it, install Scapy with pip install Scapy, and work entirely within that isolated context. Installing and using pip. Pip stands for Pip Installs Packages and is the standard tool for installing Python libraries from the Python Package Index, a central repository of thousands of open-source packages. You will use pip constantly throughout this course. The basic syntax to install a package is pip install package_name. For example, pip install requests installs the request library, which is used for making HTTP requests and is essential for web application security testing. To install a specific version of a package, pip install requests == 2.28.0. To see all currently installed packages in your environment, pip list. To save the list of installed packages to a file, useful for sharing or reproducing an environment, pip freeze >requirements.txt. To reinstall all packages from such a file, pip install r requirements.txt. This workflow is standard practice in professional projects and in DevSecOps pipelines. Verifying the installation with the first script. Once Python, pip, versus code, and your virtual environment are ready, write a simple test script to confirm everything is working. Open versus code, create a new file called hello_security.py, and write the following. Print Python environment is ready for security automation. Save the file. In the terminal, make sure your virtual environment is activated, then run python hello_security.py. You should see the output, Python environment is ready for security automation. This confirms that Python is installed, the editor is connected, and the environment is functional. Recommended folder structure for security projects. Organizing your project files from the start is a professional habit that prevents confusion later. A recommended structure for a security automation project looks like this. A root project folder with a meaningful name, such as pentest_scripts. A subfolder called venv containing the virtual environment. A subfolder called scripts containing your Python files. A file called requirements.txt listing your dependencies. A file called readme.md describing what the project does. This structure is not just aesthetic. In a DevSecOps pipeline, automated tools may look for requirements.txt to perform dependency vulnerability scans using tools like Safety or a WASP dependency check. Starting with a clean structure ensures compatibility with these professional workflows. Summary of key commands. Check Python version, Python 3 version. Check pip version, pip version. Create a virtual environment, Python 3m venv. Activate on Linux/Mac OS, source venv/bin/activate. Activate on Windows, venv \scripts\activate. Deactivate. Install a library, pip install library_name. List installed libraries, pip list. Save dependencies, pip freeze >requirements.txt. Install from saved file, pip install r requirements.txt. Having a solid, clean, and reproducible work environment is the invisible foundation of all the practical work ahead. Without it, scripts fail for unpredictable reasons, libraries conflict, and debugging becomes chaotic. Spending 15 minutes setting this up correctly now saves hours of frustration throughout the course.